Hello everyone, we're in section 5.3 and we're going to look at how to graph rational functions. So I think graphing rational functions, you have kind of a clear-cut system here to go through. First thing is you want to find the domain. Second, you want to find all your asymptotes, vertical, horizontal, oblique, etc. 3, find all your intercepts. Then you're going to plot all that and then enough extra points until you see what the graph does. So we're going to look at two examples. So here's the first one. Okay, so here's my function. I wrote r of x because it's a rational function. We can clearly see the x. We have a polynomial over a polynomial. Here I have a linear function divided by a quadratic. So the first thing I'm going to do is I'm going to find the domain. So remember here with the domain, you're just focused on the bottom. So I'm going to say, okay, what causes division by 0? Because as you know, you cannot divide by 0. Factor, pull the x out. X plus 17 equals 0. I get x cannot be 0, and x cannot be minus 17. So domain is going to be a collection of x's such that x is not equals to 0 or minus 17. Okay, there's our domain. Okay, next up we have to find all the asymptotes. So let me make some space. So let's find, this is step 2, let's find the vertical asymptotes. So first I have to try to simplify this expression. So try to simplify x plus 9 over x squared plus 17x. Okay, nothing to factor upstairs. Bottom I can take that x out. And try to see, can I cancel anything out here? Nope. So remember the vertical asymptotes are going to be here at x equals 0 and x equals minus 17. So remember, after you simplify anything that still causes the bottom to zero out, those are where your vertical asymptotes are. Alright, let's find the horizontal ones. Okay, to find the horizontal one, or the oblique, I look at, here's my function back again. I have x plus 9 over x squared plus 17x. So here I see the degree up top is equal to 1, and the degree on the bottom here is equal to 2. Anytime the bottom has a bigger degree than the top, you have a horizontal asymptote at y equals 0. Okay, so I've got the domain, I've got all my asymptotes. Remember, if you have a horizontal one, you cannot have an oblique asymptote. So I've got the vertical one, I've got the horizontal one. Now let's find the intercepts. Okay, so to find an x-intercept for step 3, I'm going to set y to 0. So here I'm setting the function equal to 0. I've got 0 equals x plus 9 over x squared plus 17x. And remember, over here, what you have is this is like a fraction. Alright, so the big question is, when are fractions equal to 0? And this happens when the top equals 0 and the bottom is not 0. Then overall, the whole thing will be equal to 0. Oops, sorry about that. Right, 0 divided by 5, so examples. 0 divided by 5 is 0. But 5 divided by 0 is undefined. So all we need to do here is I need to set the top equal to 0 and see what happens. So that's going to happen when x equals minus 9. I just have to make sure that's not going to cause division by 0, and here we know it's not because this is in the domain. So our x-intercept here is minus 9 comma 0. That's our only x-intercept. And let's see if we have any y-intercepts. Remember, for a y-intercept we set x to 0. But if I try to plug in 0, remember that's going to make the bottom equal to 0. And this is undefined. So here we are going to have no y-intercept. That's not in our domain, it causes division by 0. And one quick note here. Be careful of 0 over 0 too. A lot of students think this is 1 or 0. This is undefined as well. No dividing by 0. Okay, let's see what we've got so far. Okay, so here I kind of have all the stuff I know. I've got the domain, I put the vertical asymptotes, the horizontal ones, and the intercept. So I'm going to put these all on a graph. So let's see what happens. Okay, here's everything. Here are my x's. I've got vertical asymptotes at minus 17 and at 0, the vertical, so up and down lines. I have my horizontal asymptote here at y equals 0, and I have my 1 intercept. Okay, the way to think about these, especially the vertical asymptotes, these are walls. Nothing can go from one side to the other. It's impossible. But the graph is going to try. Around every vertical asymptote, the graph is either going to try to go above it by going up to positive infinity or below it down to minus infinity. But it's never going to be able to cross through. The horizontal asymptotes here, these are tied to end behavior. So whatever the function does for large values, it's going to go and follow this horizontal off, what I call into the sunset. So for large values of x positively and negative. You can cross a horizontal asymptote in the middle, that's okay, because it's the end behavior. It's what's going to happen for these large values of x. With these vertical asymptotes, they divide your graph up into different parts. So when I look at this, I see I've got this stuff over here to the left of this first vertical asymptote. I have middle stuff, and I have stuff to the right. So at this point, we're on step 4, where we need to start plotting points, because this one x-intercept here is not going to be enough to figure out what's going on. So I'm going to look at this region out here to the right, and all I'm going to do is I'm going to pick a value here and see what I get. I just want to figure out, just like old school, putting in values for x and seeing what the function is. And I'm going to be easy on myself. Pick a nice easy number to work with. Wouldn't put some kind of crazy fraction or decimal thing in here. I'm going to pick a nice number. So a good number to pick out here would be 1. It's out in this region, and I'm going to plug in 1 and I'm going to see what I get. So let me give myself some more space here. Okay, R of 1. So I'm inputting in 1 for x. And I like to put things into the factored form, so I think it's a little bit easier. So I have 1 plus 9 over 1, 1 plus 17. And then I'll see what I get. So this gives me 10 over 1 times 18, which is 10 over 18, which is better known as 5 over 9. And that gives me a point. X is 1, the y value is 5/9. So okay, if I put in a 1 for x, not quite at 1, I'm like halfway, I have this point right there. That's a point I can put on my graph, just like old school, picking values for x and seeing what the function is. This 1 point is enough for me to figure out this whole part of the graph, just 1, because here I don't have any other vertical asymptotes out this way. So this graph, in terms of end behavior, is going to follow out the asymptote out this way and get closer and closer and closer, and continue on. Up here, I have one of two things that can happen. It's either going to try to climb the wall going up, or it's going to climb the wall going down. And we know which way it goes. The graph has to go up like this. And the question is why? Why does it have to go up? And I have a lot of students who will tell me, well, it's positive, so it's got to stay positive. And that's not quite right. The reason why it's got to go up is that if it had gone down, you would have another intercept here, and you don't. Since you don't have any x-intercept, there's no way it could go down because it would have to cross this x-axis. That's why finding the intercepts are a very, very important step in this. That's how we know it's got to go up and not come down. And we have this whole part of the graph figured out. If you're unclear, then all you need to do is put in more points. Plug in a half, see what you get. Plug in 2, plug in 3, plug in 4. But for me, 1 point will do it. I have this graph figured out. And now I'm going to work on this section here. So again, I'm going to need to plot points. So let's see what happens if we plug in, for example, -1 in for x. Let's see what we get. So I'm going to give myself some more space. Okay, I'm plug in -1. So in for all x's. Up top, I get 8. I'm going to get -1 times 16, which is 8 over -16, which is better known as -1/2. So when I plug in a -1, I get -1/2, which is right there. Okay. Again, since this guy is here, I know the graph is going to have to go something like this. And at that point, that's going to try to get over that vertical asymptote. And it's got to go down again, because if it went up, again, we'd have another x-intercept, and we don't. Now here, I still don't know whether this guy goes up like that or down like that. So I've got to plug in one more point here, and just to make myself be sure about it, because no one knows. I know it's not going to cross the x-axis at all. I know it's going to try to climb this wall by either going up or going down. So I'm going to plug in like r of -10, and I'm going to see what we get. Okay, so I plugged in -10, top and bottom, did the algebra. Let's see, top turns into -1. Here I have -10 times a positive 7, that's -70, and negative over negative turns positive. So at -10, the function is at 1/70th, which is like right there. Okay, since this is above, it's got to stay above. It's going to try to climb the wall that way. Alright, I have one more region to figure out here. So a good number to plug in out here would be -18. So I'm going to give that a shot and see what happens. Okay, here's minus 18. In for all x's, I simplified everything and I get minus 1/2. So I plug in minus 18, like right there. Again, that 1 point's enough for me to do this. I know I can't cross this x-axis because I don't have any more x-intercepts. So this guy's going to follow down that asymptote there. And then this is all end behavior. So he's going to follow him out to the sunset. And there's our nice graph. Okay, I know it's like a lot of steps, but remember, 1, do the domain, 2, find all your asymptotes, 3, do all the intercepts, and then plot enough points so you get the picture. Okay, we're going to take a look at one more example. Alright, here we go. We're going to try to graph this function. So, step by step. First, 1, find the domain. I have a rational function, which is a quadratic over a quadratic, polynomial over polynomial. So I take the bottom, and I set it equal to 0, because I know no division by 0. This factors to x plus 5 and x minus 2 is 0, which gives me x cannot be minus 5 and x cannot be 2. So I'm going to write the domain over here. Function of x is such that x cannot be minus 5 or 2. Okay. Now I'm going to find all the asymptotes. So I have function x squared minus 25 over x squared plus 3x minus 10. I'm going to do the horizontal asymptote first. Degree on top is 2, degree on bottom is 2, so it's a tie, so I have the coefficients. So y equals 1 over 1, which is better known as 1. And for the vertical ones, I need to simplify. So let's see. Upstairs, I have x plus 5 and x minus 5, which is my difference of 2 squares. The bottom, we already know how that factors. It factors to x plus 5, x minus 2. And now this cancels out with this. And I have x minus 5 over x minus 2. So I only have a vertical asymptote here at x equals 2. It's my only one. It's my only problem still in the denominator. So the question is, what's happening at 5? So at x equals minus 5. What do we have? Because it's not in my domain, it's not a vertical asymptote. So any problem like this where it's something that screws up the domain but can be simplified, you have a hole at this value. So I'm going to write that down. I have a hole at x equals minus 5. Just like, kind of like with a piecewise function. So this is going to be an open circle here. It's not an asymptote, it's just a hole. Okay, let's find the intercepts. Okay, x-intercept, I set y to 0, so here's my function set equal to 0. Be careful. So remember, we talked about last problem, that we need to set the top equal to 0. But when you're working with these, what I would do is I would work from simplified form. Because we already know what's happening at minus 5, we have a hole there. So it's not going to be any kind of intercept on our graph, so we need to be careful. So really, all I'm dealing with is 0 equals x minus 5 over x minus 2. So here I'm just worried about the top, so 0 equals x minus 5, add 5 both sides. And I have 5 equals x. I have one x-intercept at 5, 0. Okay, let's find the other intercept. Alright, the y-intercept, I'm going to set x to 0. So I'm going to find, well, what is f of 0? That's going to be, let's see, I like either way, plug in the factored form or this one. I'm just going to plug in right up here. So I have minus 25 over minus 10, which is negative over negative, is going to turn positive. And then let's simplify this to be 5 halves. So my y-intercept here is 0, 5 halves. Alright, now we're going to start to put this all together. This would have worked if you plugged into the factored form as well. Okay, so here's my function. Here's the simplified form of my function. I put in all my asymptotes here, horizontal one and the vertical one, and I put down all my zeros. And I'm going to take care of this hole first. So to figure out where the hole is, you plug it into the simplified form. So I have minus 5 over minus 5 minus 2, which is minus 10 over minus 7, which is 10 sevenths. So when I plug in minus 5 for x, 3, 4, 5, I am at 10 sevenths, which is 1, and then some more sevenths, which is right there. And I'm going to do an open circle. There's the hole in my graph. And that gives me enough to do this whole part over here, because it's going to follow out the horizontal asymptote. I know it's got to come over here and hit this point, and then it's going to try to climb this wall going up. Can't go down because I don't have any x-intercepts here. Okay, now I've got one more thing to do. I just have to figure out this part of this graph. And I'm pretty confident about what's going to happen out here. I know it's going to follow out this horizontal asymptote this way, so I know it's going to go there. It feels like the graph's going to go down this way to climb out, to try to climb over this wall going down, but I'm not quite sure. So I think if I plug in one of these 2 points in here, just give me one more point, I'll be 100% confident. So that's what I'm going to look at. Okay, so I'm going to plug in 3 and see what I get. And as long as you stay away from this hole, you can plug it into the simplified form. You're going to get the same result. So I got 3 minus 5 is minus 2. And 3 minus 2 is 1. This is better known as minus 2. I plug in a 3, I'm down here at minus 2. And now I'm 100% confident this guy's going to go down and try to climb the wall that way. So that's how to do a rational one when you've got a hole in the graph. Alright, I hope this was helpful to you guys. I'm going to do a nice little smiley face here. Good luck graphing these rational functions.